Boom! Yes, folks, Hume here again, and we're continuing with the series of videos on completing the square. Alright, so we start from point A, we go on to point B, we go on to point C, and so we go on. So in the last video, we would have developed a particular pair of relationships, having started from the first video where we looked at the x plus h in brackets all to be squared and the x minus h in brackets all to be squared. Alright, so we're going to take it. You see the relationships on the board. Let us get the show on the road. So we know now, and we could take this as a thing that is just how it is. We don't have to ask any questions. We don't have to debate. We don't have to wonder if, when, where, why, and how. We could just take it as is, that x plus 2h, x is equal to x plus h squared minus h squared. We could take it also that x squared minus 2hx is x minus h all to be squared minus h squared. Now, the next step is to put some meat on the bones. In this particular context, what does that mean? It means that we're going to just introduce some numbers into the situation now. So far, we would have dealt with just the abstract, the letters, the general case, etc., etc. When you start to put numbers into it, that is when it starts to become concrete. That is when people start to get it. That is when it starts to click. So, click time started now, right? X squared plus 2hx, right? What does that mean? It means that if I have, watch it now, x squared plus 8x, right? I could write this over as, watch it carefully now, x plus 4 squared minus 4 squared. And the reason why I could do that is because if 2h is equal to 8, then h is equal to 4. So in other words, what it says is that if we have the expression in this form, whatever the coefficient of x is, we can write it over in this form, provided that we take half the coefficient of x here and half the coefficient of x here as well. Alright? So if I say, let us say x squared plus 10x, I can write that over immediately as x plus 5 squared minus 5 squared. Alright? And we just went through our whole procedure to get to this point. So at this point, we're no longer guessing, we're no longer just cramming. We're here because we understand a particular procedure. Right? By the same token, I can say x squared plus 98x is equal to what? X plus 49 in brackets squared minus 49 squared, whatever 49 squared is, right? Etc., etc., etc. Right? You can run a few more again, just for the sake of making it a little more absolute, right? Sometimes you have to drum the point home repeatedly, repeatedly, repeatedly. So I could say x squared plus, let me see, big number, 250x is the same thing as plus 125 squared minus 125 squared. Notice the pattern. Whatever the coefficient of x is here, we always have half of that inside here and half of that outside here, squared, right? 2h here, you have h here, and you have minus h squared outside here, right? I could say x squared plus 4x. That will just simply be x plus 2 squared minus 2 squared. I could say x squared plus, let me see. Let me give them a small number. X squared plus 16x is equal to x plus 8 squared minus 8 squared. And if I say x squared plus 1000x, that would obviously be x plus 500 squared, or to be squared minus 500 squared, etc., etc., etc. Alright? And we're going to do the same thing for x minus h to be squared. Well, x minus 2h x, right? So we're going to do the same thing for the negative now. And we're saying, essentially, that just as we did for the positive, we're doing the same thing for the negative now. And I can say, therefore, that I can say, I don't think I'll be needing you anytime soon, or you. I can say, therefore, that x squared, excuse, minus 6x is the same thing as x minus 3 squared minus 3 squared. I can say that x squared minus 14x is the same thing as x minus 7 squared minus 7 squared. I can say that x squared minus 56x is the same thing as x minus 28 all to be squared minus 28 all to be squared. Right? Let me go and do some more again. Alright? We could say, let me choose some crazy looking numbers now. We can say that x squared minus 256x is equal to x minus 128 squared minus 128 squared. Again, note the pattern. Whatever the coefficient of x is, you take half of that inside here, and we take half of that outside here, and we square it. Note also that the sign here follows the sign here. So if you have x squared minus 256x, you'll have x minus 128. If it was x squared plus 256x, it will be x plus 128 squared here. But this minus sign remains constant regardless of whether you have plus or minus here. We're going to mix them up a little bit just now. If I have x squared minus 96x, that is the same thing as x minus 48 all to be squared minus 48 squared. If I had x squared minus 2300x, that is the same thing as x minus 2300 is what, by 1150 squared minus 1150 squared. Alright? Etc. 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 Right? So now we're going to mix them up. Right? We're going to mix them up, throw them all together, and see what we come up with. Alright? So, mixing it up now. So we mix it up, and we're saying that if we have, let us say, x squared minus 32x, that is the same thing as x minus 16 squared minus 16 squared. What about if I have x squared plus 32x? Well, because we have a plus sign here, it will be x plus 16, right? All to be squared, but the minus 16 remains the same. So you're always minusing on the outside here, right? The square of half of the coefficient of x. The coefficient of x here is 32. Half of 32 is 16. 16 squared. The coefficient of x here is 32. We leave out the minus sign for the time being. 32 here. Half of 32 is 16. But because we have minus 32x here, then inside here in this bracket we have x minus 16 all to be squared. So in other words, this sign follows this sign. This sign follows this sign. The minus sign here is just the minus sign in all cases. Alright? Let us see. Let me try some different numbers now. If we have x squared plus, let me see, boy, x squared plus 192x, that is the same thing as x plus 96 squared minus 96 squared. If I have x squared minus 406x, that will be x minus 203 squared minus 203 squared. Alright? Let me go again. Right, let me go a couple more rounds and then we'll call that George for this particular video. Right? If we have, let us say, some smallish numbers now, x squared plus 24x, that will be x plus 12, 12 being half of 24 of course, all to be squared minus 12 squared. And if I have, let us say, x squared minus 52x, that would be x minus 26, all to be squared, minus 26 squared. And that is it. That is it. That is it. Once you could do this, then the stage is now set for the first level of questions where completion of the square is concerned. Alright, and we're going to do that in the next video. So again, you see, we're taking our time step by step. We're not rushing, right? So even if maybe I'm going a little kind of fast in the video at some points, it's simply because at those points we at a particular place where we could just run, we just rotate, choose a number, we go in, we have a particular template and we could just substitute a number into it and keep it running, and we could change the numbers for as long as we like. The process is the same. Alright, so in the next video we're going to take this result, and insert it into actual questions where we have to complete the square. And once you could do that, the gates start to open now, and you realize, oh wait, I could do this. And once you realize that you could do that for this level 1 type of situation, and you will see later on why we call it level 1, then the step up from level 1 to level 2 with just a slight layer of complexity in terms of additional arithmetic, but that is simply the name of the game and we just have to do it. Alright, so as always, keep good, take care of yourself, and look out for the next video.